Hello everybody, welcome back to the channel. This is Michael, KE4EST. And right off the bat, I'll tell you I'm trying to fight a cold here, so I wanted to do this like 3 or 4 days ago, and it's kind of clearing up now, so if I sound a little funny, you'll know why. So anyway, let me find my favorite pointer over here. This been talking about on like satellite guys for a while. As you know, a lot of you know, the ones that's familiar with this and keeps up with free to air stuff and C-band stuff knows that last summer, you know, Brian at Titanium Satellite discontinued the famous ASC1. And really, if you're, look around, it's hard to find a good dish mover. I mean, you can look around and find some V-boxes here and there, and they want way too much money for them. I know I sold them, but they're, the only game or two in town here and there, so you got to go, they know that. But if you're a little bit crafty and know a little bit about electronics and microcontrollers and stuff, it's not real hard at all to make your own. I mean, you can get real fancy with them, have some neat features on them, if you want to make your own controller. But making just a plain controller to move a C-band dish is not that hard at all. I'll draw up a little quick schematic here in a minute. Won't be a full schematic, but you'll see what I mean. I'll just kind of go over it and show you, so if you're, this video is not, how to use a microcontroller, how to program, how to use Arduino. There's plenty of stuff out there for that. This is assuming you already know all that stuff. You're familiar with microcontrollers. You've got some electronics background, and you know kind of what's going on with that. But maybe you just don't, putting 2 and 2 together to click and go, oh, okay, that ain't that bad. There ain't no magic to those things. A lot of people think it's really complicated, but it's not. They're real simple inside. Some of them's really simple, too simple actually. And you can get fancy with, you can have, a simple one where you push a button, mash this button, dish goes west. Mash the button over here, dish goes east. Let go, the dish stops. I'm just rattling on here. But, these things, I just, I want you to realize they're not that hard to do. They're not whatever. And this one here is just something I've got set up as a proof of concept. This display here, that's a Arduino Mega and an adapter board to run this 5-inch display. This is touchscreen. Don't have to be touchscreen, but when we've talked about this on the forum, and stuff, a couple of guys say, hey, we need to add touchscreen capabilities. Well, I did it just to show them you could do it, but you don't have to. You just have push buttons. This one's got both push buttons, and that just set up for proof of concept. It's not hooked up to, the full. There's not a full controller here. I've got ones I've built before in the past and made, and they work fine. But this one here, I started from scratch. Because the other code was kind of kludged up and kind of, a mess that I did years ago. So this one here, I thought, I'm going to start from scratch. I'm going to write a new code from a blank board, just start over, and add the touch screen and whatever. And of course, you don't see a save button. You'd want some kind of save button here. Like I get the dish where I want. I'm going to save this as 87 West, and you'd want it to pop up on the screen and say, that's another neat thing you can do. A lot of the plain Jane controllers, they don't tell you that. They may tell you where you're at here, or they may say, like the V boxes will say P8, P9, or whatever when you move it to a pre-programmed spot. But it'd be nice to show all the information. What is our counts here? What satellite am I on if I've got it pre-programmed? Even if you got plenty of real estate here on the screen, you can have little numbers over here just to kind of remind you where your east and west limits are set. Things like that. So you can get add all that stuff, and then you could, like I said, you can go crazy with it. And but best way to start off simple. And this one here I've got set up. If I hit this west button, you see I've got this LED. You kind of see a green one coming on down here. On the screen it's saying west and a green dot. Now if I hold, and you notice there's nothing moving here because I don't have it hooked up to a dish. I've got a button here to simulate pulses. If I hold the west, see how the light went out. We got red and it says west error. Now you wouldn't want it to wait that long. I've got it set purposely. The delay is that long, just because I'm shooting this video. Because that's, I think, a second delay or something. Because that dish can move quite a bit across before it, hey, or the dish is going to flop or something ain't right somewhere. So you'd want to have it about. What I found out worked out really good with my other one was 300 milliseconds. I know people like with the ASC1 come in and ask, hey, can we get that changed to half a second because we get noise, or we get this, or we get, I'm using this kind of motor, I'm using this dish mover, I'm using that mover, whatever, and it ain't working. So I think Brian finally had it set up to a half a second. But it really should be 100 to 200 milliseconds. But sometimes it will get a little, even though nothing's wrong. So I found the best sweet spot was about 300 milliseconds. If I press this and this ain't counting within 300 milliseconds, something's wrong. So it needs to stop. I'm trying to push that dish, shut the voltage off going to the motor. But you can see I've got a little button here, so if I push west and I start counting, the numbers are changing. Now, of course, you'd want this bigger too. This is just set up just to proof of concept. You'd want this bigger. I would, where I can kind of look across, if it's sitting under my TV or something, I want to be able to look across the room and see, I'm on 87 West, 91 West, whatever. I'm just pulling a number out of the air, but I'm whatever. I can see what my count is if I want to kind of bump it, a little bit. And you'll start to memorize this stuff. If you're new to this, you'll start memorizing it. You'll start knowing that when I'm on 87 West, this is on 14. When I'm on 89 West, this is on 25. Under normal circumstances, you'll start figuring that out and memorizing it. And you're like, hey, that don't look exactly right. Or, well, it's usually 25, but let me bump it to 24. Things like that. And I know this video is getting a little long, but I may break it in two parts. I don't know yet. Make it easier to swallow because I'm going to go over quite a bit of stuff. So, but this is what I've got set up, and I'll show you what I've done. But you got east and west, just to show you can hit the buttons here. And if I go east, you can see I tap it. I can bump the dish. Say if I was bumping the dish. See, it's throwing on and all I've got is, through a resistor here, it's turning this LED on. Same way for the west side. Just showing you that it's actually doing, you don't want this to go through a transistor to the relay, drive a relay, because the microcontroller itself ain't going to be able to, drive a relay. So it would have to go through a transistor and turn the transistor on. The transistor drives a relay. Unless you did something with a MOSFET or something where that would, you could use like a PWM signal going into the MOSFET to give a slow start and a slow stop on the dish. But you can see I got it set up there. Let me move the camera a little bit and we'll look at something else here. So what I've got over here, not counting the display and stuff, we've got the Arduino. Of course it gets power, it's programmed. And then we got, if you use touchscreen all the time, but I'd recommend if you want to play with touchscreen and have it, that's neat, especially bring up menus and stuff, it's really quicker. But still have some hard buttons, some momentary buttons for east and west. But I've got one going out for a button for west. I've got another one for another button for east. Then we got our pulse pin. Okay. What you would do with it is, if you want to feed 5 volts, 5-volt signal out to the read switch on your dish. Okay. And then that read switch is going to open and close as that dish moves. So that's going to send those 5-volt pulses back here to this pin, and it's going to read them. Okay. So, and then that's that. Oh, we're also going to have, coming out of the Arduino, we're going to have a west and an east. Okay, pin that's going to go high. You push west, you want west to go high. You're going to want that to go through, I ain't going to draw the whole circuit, but you want to go through a transistor circuit. Let's draw a block. Okay, and then that's going to come out. Right, we'll call that X. Same way with east. It's going to go through a transistor circuit. Okay, and Y. We'll call that Y. No reason, just whatever you want to call it, A, B, or C, for all I care. But okay. So when I push this button here, you know, it's programmed, everything's running. I push the west button. This pin's going to go high, turns transistor on. Okay, which is going to cause, this is going to go, these here is going to go to your relays. Right? To activate, this would be the west relay and this would be the east relay. Okay? So that's what's going to happen there. So, then, let's see, I've got pre-drawn up here about the same thing here. I hope there's not too much of a glare on this pencil marks. So here's your microcontroller here, going through NPN transistors or N-channel MOSFETs. Then here's your X and Y again. Here's your relays. This right here is your relay, and this one is, well, I didn't really mark it, but I guess it really don't matter. This is just showing you what happens. So here's how you'd wire up a relay. Of course, your relay is going to have, you know, pins for coil, and that's what this is here. It goes off to your coil, but I've already got it here. You always want to have that diode in there. Too far zoomed in. Gotta have that diode. Okay, don't forget that. Just a small diode. Clamp that pulse when that relay opens and closes, or you're going to damage your microcontroller. Like I said, this ain't a video about how electronics works, but I can do a follow-up video or discuss it on Salad Guys if somebody really wants to know about that. But look it up, Google it, about putting the diode across your relay. Okay, so you want to go to this, what do we call X? West? Let's just do that. This is west and this is east. So say we want to go west, we push that button. Okay, I push that button. This is going to, we've got this relay on the coil on this relay here is our west relay up here, tied to positive voltage, whatever, you know, if it's a 5-volt relay or 12-volt relay. A lot of times these you'll have different, you know, you'll have your voltage, your 36 volts or thereabouts going to your motor. You'll have, you need 5 volts or 3.3 volts to run your microcontroller over here. And then you'll need, you know, whatever the relays are, you know, the coil and the relay. So anyway, we turn this on. This is going to energize this relay. Now, before the relay energizes, have a look at this. This is going out, this here is going out to your motor. Motor is over here. Okay. So here's our power supply up here for our 36 volts. Okay, and it's coming down here to the normally open side of this relay, and I've kind of got it just wiggly through here so it don't get crossed up something else. To right here to normally open. This is normally open side of this relay. So there's 36 volts sitting there. On the normally closed side of the relay, let me do this. You can tell there's been a double take here. A lot of times you'll have to do 2 or 3 takes on these things before I get it where I want it. Okay, so the normally closed side of the relay is tied to ground. And I've done that on both sides here. Okay, so we've got 36 volts going into here, and on the closed side we got it grounded out. Now this side over here, the part that flips back and forth, the switching part, that is going out to one motor wire. Yep, I should have erased that too. This is going one motor wire, and this is going to the other motor wire. Don't matter. This is black or red, whatever. It ain't, you know, you'll want to switch them when you get it set up. Like if I push the west button and the dish is moving east, flip these wires around on your terminals, you know, on the back of your unit, so that, you know, you've got it backwards the way the controller is set up. So everything's sitting here like that, and that's, you know, that's a good way to do it in good practice. Both wires, when nothing's happening, dish ain't moving, both wires coming from the motor are going to ground. Okay, so let's say we want to push the west button. So we push the west button over here. This gives this just shows X, goes to this X here. Energizes our relay. When our relay energizes, this is going to go here. So we're going to give plus to this wire, and this wire, of course, is still setting it minus. So the dish is going to move one way, right? The motor's going to turn clockwise. Let's say it moves clockwise. Alright. Let's go back to where we was at. Now we push the east button over here. Y goes to Y. Energize this relay. This is going to jump up here to there. Alright. That gives our 36 volts to here, so this is going to be positive. Okay. And where's this at? It's going to ground. You know, it's normally just sitting there at ground, so we got minus here, so the dish is going to move counterclockwise and move the other direction. And the motor, but of course the turn is going to cause the dish to move one direction or the other. So that right there is, you know, basically how it's set up. You know, and there's things you can do if you have this is just a single relay, single pole, double throw here, goes one way or the other. Normally open, you have relays that's got 2 sides to them. With something else that you can do, you know, just thinking of some extra features you could add or whatever, just for double protection. You'd want to, you know, have it in the software for sure that if I press the east button, it locks out the west button. It can't move. You cannot get that west button to do anything. And I failed to show you that, and I had the camera over on the thing, but I've got it set up that way. If you press the east button and the dish is moving east, you try to push west, nothing's going to happen because you don't want to energize both relays. That's not going to be good. If you had a relay that's got another set of contacts in it, okay, you can go in and have the other set of contacts on the normally closed side of it, going through this signal that's coming in to turn the to energize the relay. So you can have a set of contacts here, okay, that's going in, and this would go back to, this would go, this here for, this one would go up from this relay up here. So when I push west, so like normally this would be normally closed here. Okay. When I push this west button over, I push the west button over here, this relay energizes. It's going to cause this to open. Alright, there's something else you can think of. It's going to open that. So now not only is it software set up that you can't activate both relays, this relay is energized. It's going to open up the wire that's going to the coil on the east relay, so this relay can energize. And if you did fail to mess it up, do something wrong in the software, or the software went buggy or crazy, so it can't activate both relays. This one, it goes first. This one ain't going to open. And believe me, you can try all day to push both buttons at the same time. One's always going to be a little faster than the other. It's just the way humans are, the way it is. They can run it, looping so fast looking for a button press. It's just you're not going to hit both at the same time. So, one other thing here too, I'll show you. This power supply. Let's see. Let me just draw this again. Say we've got, because you either want two separate transformers, one that can provide lower voltage, go through a voltage regulator for 12 volts if you got a 12 volt relay, and 5 volts, or 3.3 volts for your microcontroller. And you want your about 36 volts. It don't have to be 36 volts. You don't want to go too much higher than 36 volts, so you can go low. I've seen people set them up purposely to run 24 volts, so the dish will move slower. Anyway, but let's talk about the transformer. I just want to show you something real quick that a lot of people don't think about. I've seen a lot of people have this problem. When you pick your transformer, be careful. Don't go looking for a 36 volt transformer. Go 24 to 30 volts, maybe maximum. RMS AC output. When you put 120 volts in, because that's normally about what it is now. A lot of people still call it 110, but it's about 120 to 125. But average is about 120 in North America. You want 120 in and about 24 volts out. Because when you take it and you run it through, you can buy these bridge rectifier blocks like this. I would just use standard, if it were me, just standard diodes. But when you come out of that, just ground that out, you've got, say 24 volts, let's say 24 volts here. You rectify it, run through a filter capacitor, and that's it. I mean, that's all you really need. Just don't need no regulation or anything. Let that voltage swing a little bit as that motor pulls on it. That's it. You can take this, and like I've showed over here, and you got it straight out. Okay, you got it straight run out. There's your voltage. Okay, but let's say we got 24 volts. Let me get a calculator. Alright, let's just do it this way. That's going to have a glare, but say we've got 24 volts RMS. You got to remember, this is going to bring it up to the peak when you rectify it and put a big old capacitor in there. So 24 volts, and you take the voltage times the square root of 2, and we'll just round off to 1.14. That's what I had. That's why that was written on the paper there. So times 1.414. So right here, you're going to have, this says 33.9, we'll say 34. We're at 34 volts right here. And you got a 24 volt, so it's 24 volt transformer. So a lot of people don't realize that, and they'll also, I've seen them taking, say, underrate this capacitor too and have them pop when they're building circuits. I say, why does this capacitor keep popping? This is 24 volts and it's a 30 volt capacitor. Why does it keep exploding on me? There's nothing shorting out. I don't understand that. Well, you're getting, measure your voltages. You're at 34 volts over here. So say you go Well, I need 36 volts, buddy. So you find 36 volt transformer, it's going to put 36 volts out RMS. Alright. So let's do 36 times 1.414. You see that? You'd have 50 volts right here. Those motors are rated for about 36 volts. They'll go a little bit more, and they'll of course go less, but you have 50 volts. Bad idea. Bad idea. So anyway, I'll go in this video here. I just want to show you that little last part real quick. You don't want that. So watch how you size your transformer. And I will part 2 of this, I'll go over the software and what I did in the software, so you can kind of see that if you're rusty on it, whatever, and kind of get in your mind how I did things and whatever. And I'll catch you in that video. This is Michael, KE4EST 73.